Alright, in this video here we're going to take another look at solving a trig equation and do a more complicated type of example. So if you haven't seen the other videos that I've done on solving trig equations, you might want to check those out before this one. We're kind of building up into more and more difficult types of equations. So the first video that I did, the equations were pretty simple and I explained in a lot more detail what we were doing and kind of the methods we have to use. And now we're getting to more complicated types of equations. So the equation we have now, 5 times sine of theta times cosine of theta plus 4 times cosine of theta equals 0. Right, so you might look at that and be like, well, I don't even know how to begin this because, I'm multiplying a sine times a cosine. How am I supposed to figure out how all this stuff is supposed to add up to 0 and like what angle is going to make that work? And you're right, like, to actually do that the way it stands here is, I want to say it's impossible. If you're like a trigonometric genius and you can juggle all the values of the angles and everything in your head, you might be able to figure that out, but most people cannot. Right, so what we need to do then is look at this and think of other techniques that we've learned for other types of equations in the past, and can we use any of those techniques to solve this? So if you notice, well, this term right here, this 5 sine theta cosine theta, that has a cosine theta in it, and my other term, the 4 cosine theta, also has a cosine of theta. They have a common factor. Right, so I can use my factoring strategies and I can factor out that common factor. Right, so let me do that. Let me pull out the cosine theta, which is going to leave me with a 5 sine of theta plus 4 equals 0. Right, so that's another strategy you can use sometimes with trigonometric equations. If you have trig functions multiplied together, likely you're not going to be able to solve that equation as it stands, so look to try to factor something out, right? Try to pull out, anything they have in common. In this case, the two terms have the cosine in common, so I can pull out the common factor of cosine theta, and that leaves me with this. And once I do that, now that I factor this, I have two things multiplied together that equal 0, I can separate those factors, right? It doesn't matter what my factors are, right? So cosine theta equals 0, and 5 sine of theta plus 4 equals 0. Right, so it doesn't matter what those factors are. If it's an x times a 5x plus 4, set each of those equal to 0. Or if it's a cosine theta times a 5 sine theta plus 4, separate those and set them equal to 0. Right, the factoring method works no matter what is contained, or what your factors look like or anything like that. Factoring is factoring, right? Whether it's just x's or whether it's sines and cosines or e to the x's or natural logarithms or whatever, factoring always follows that same pattern. So that's one of those things about higher and higher levels of math. The previous techniques that you learned, where we learned factoring applied to just like quadratic equations and maybe other types of polynomials, but you can use that same technique even when you're dealing with trigonometric equations, right? It comes up every once in a while, right? So you have to kind of, when you're looking at a problem and you're not sure how to begin or what to even do with it, Look for the structure of it. Like, what's going on here? Well, I have cosine and cosine. Does that look similar to anything I've seen previously? Or is there anything I can possibly do with that? Right? You have to be a little bit creative with it and think, well, what other techniques have I learned in the past? Like, I haven't done anything like this yet with trigonometric equations, but is it related to anything I've done previously with quadratic equations or polynomials? Right? Is there any of those techniques that I can use and apply to this type of equation? And in this case, we can do the factoring a common factor. Right, so that's one of the things you have to think of when you are when you're faced with a problem that you don't know how to do. You have to think about other techniques that you've learned. You've learned something along the way that will help you solve that problem, right? Your teacher's not going to ask you to do a problem that you don't have the ability to do or you don't have the knowledge to be able to do. Sometimes though you have to think a little bit. You have to pull different resources together in order to figure it out. All right, which is what we're doing here. All right, so I separate my two factors, cosine theta equals 0, 5 sine theta plus 4 equals 0, and now I solve each of those individually. All right, so cosine of theta equals 0. So where does cosine equal 0? Well, if I go to my trig hand, all right, cosine is my x-coordinate, so my x is going to equal 0 if I put down my thumb, which is not something we usually do with trig hand. Usually it's one of the fingers in the middle here. But if I put down my thumb, I have 0 fingers above, so my x-coordinate is 0. I have 4 fingers below, so my y-coordinate would be root 4 over 2, or 1, right? Root 4 is 2, so 2 over 2 equals 1. So, on the unit circle, cosine equals 0 up here on the positive y-axis, which is at the angle of pi over 2. All right, that has a terminal point 0, 1. All right, so cosine theta equals 0 when theta is equal to pi over 2. And cosine theta is also going to equal 0, right? X also equals 0 when I'm on the negative y-axis, right? That has the terminal point 0, negative 1. And that's the angle of 3 pi over 2. Right? And those are angles that you should know from the unit circle, and you should know those terminal points. Those are like some of the basic ones, like the positive and negative x and y axis. Like you should know those and what those angles are. So you shouldn't have to use your trig hand to do that. You should say, all right, cosine equals 0. That's my x, so x equals 0 up here and down here, and that's pi over 2 and 3 pi over 2, right? So you should be able to figure that out at this point without doing too much extra work to get that. All right, so those are my two solutions for cosine theta equals 0 on one period of the graph of this function. To get all of the solutions, remember, and I explained this in some of those other videos that I did, the first thing we do is we find the solutions in one period of our function between 0 and 2 pi, right? So on one trip around the unit circle from 0 to 2 pi, there's two places where x is equal to 0, or where cosine equals 0, at pi over 2 and 3 pi over 2. But if I keep going around the unit circle multiple times, I can go around 7 times and then still end up at this same point, and the cosine of that angle is still going to be 0. Right? So adding this 2 pi k, right? The k represents any integer, right? Any positive or negative whole number. So that's just saying if I go to 3 pi over 2, and then I can add however many laps around the unit circle that I want to in either direction, and I'm going to end up at that same spot, and cosine of that angle is still going to equal 0. Right, so that plus 2 pi k that we put at the end of our solutions covers the infinite number of solutions that we actually have to this equation. Right, if you think about the graph of the cosine function, it looks like this. Well, cosine equals 0 an infinite number of times, right? Every time that wave graph crosses the x-axis, which it does twice in every period, the cosine of theta equals 0. Right, so this 2 pi k covers that infinite number of solutions. It describes all of the possible solutions to that equation. Right, so that's why we have to put that 2 pi k when we're asked to find all the solutions to the equation. All right, so those are two solutions that generate an infinite number of solutions to my original equation, right? But those two just came from this one factor, cosine theta equals 0. Now we have to deal with our other factor, which was 5 sine theta plus 4 equals 0. Right? So now I have to solve that one for theta. All right, so the first thing I have to do here is isolate my sine of theta, which means subtracting the 4, I get sine theta equals negative 4. I get 5 sine theta equals negative 4. And then I divide both sides by 5. So I get sine of theta equals negative 4/5. All right, so sine theta equals negative 4/5. Now, like what we did here where cosine theta equals 0, 0 is one of the numbers I know from the terminal points on the unit circle, so I can use the unit circle there to get the exact answers, pi over 2 and 3 pi over 2. Right, sine theta equals negative 4/5. Negative 4/5 is not one of those numbers that I recognize from the terminal points on the unit circle. Remember, those terminal points are 0, 1/2, root 2 over 2, root 3 over 2, and 1. Right? 4/5 is not one of those numbers that I just mentioned. And so when we get a value like this, we need to use our calculator to get our solution for theta. Now remember, technically what we're doing here is we're doing the inverse function on both sides of the equation. Right? So I do sine inverse on both sides. The sine inverse cancels out the sine function, which isolates the theta. So I get theta equals sine inverse of negative 4/5. Right, remember, anytime we're trying to solve for the angle, we're trying to solve for the theta or the x that's inside the trig function, we have to use the inverse trig function in order to solve for it, right? Because the inverse function is what cancels out that original sine function. Right, so I have to do, make sure my calculator is in radian mode, which it is, and I have to do sine inverse of negative 4/5. So I type that in, right, sine inverse negative 4/5, I hit enter, and I get negative 0.927295, whatever. So I have here theta equals negative 0.93, let's call it. All right, so negative 0.93, that is my solution to this equation, 5 sine theta plus 4 equals 0. All right, now, is that the only solution in one period of this function? Usually not, right? When we're dealing with sine and cosine functions, generally we get two solutions in any one single period of the function. Right, just like we saw here for cosine theta equals 0, we got two answers between 0 and 2 pi. Right, well, for this one here, sine theta equals negative 4/5, we're also going to get two answers between 0 and 2 pi. So let's try to figure out where that other answer is going to be. All right, so theta equals negative 0.93, so it's a negative angle, which means it's coming down this way, and my sine was equal to negative 4/5. All right, sine is my y-coordinate, so this is going to be like down here somewhere. Right, this is going to have a y-coordinate of negative 4/5. Right, because sine of that angle equals negative 4/5, and sine gives me the y-coordinate of the terminal point on the unit circle. Right, and this angle is negative 0.93. All right, so that's where, and where this point is exactly is not that important. What's important is that it's in the fourth quadrant. Right, don't put that point up here or over here somewhere. This point is going to be somewhere in the fourth quadrant. Exactly where you put it on the circle is not that key right now. We're just going to use this generic point in the fourth quadrant to figure out, well, where else am I going to have y equal to negative 0.45, and what is going to be the measure of that angle, right? So if I reflect this over to the third quadrant, right, at this point over here, I'm also going to have a y-coordinate equal to negative 4/5, right? Because I'm just reflecting, I'm below the x-axis, so my y is staying negative. Now if I just reflect that over to the other side of the unit circle, over into the third quadrant, I'm going to have that same y-coordinate, all right, as long as that line I used to reflect it is just a horizontal line. All right, so then the question is, well, what's this angle that takes me to that point over there? Right, and once again, use the symmetry of the unit circle. Right, if this one is 0.93 below the x-axis, this one over here is also 0.93 below the x-axis. Remember, the negative x-axis, halfway around the circle is pi radians, so I have to do pi plus another 0.93. Right, and again, it's all about the symmetry. Right, this is 0, and then I'm going down 0.93. Here, I'm doing pi and then plus another 0.93. Right, because I'm adding more to the angle here, whereas here I'm subtracting the angle. Here I'm adding more to the angle, making it bigger as I rotate it around this way. So I have to do pi plus 0.93. All right, so pi plus 0.93 equals 4.07. All right, so when I type that in the calculator, 4.07, so that's my angle here, is going to be 4.07 radians. All right, so theta equals also here 4.07. And for both of these, just like the ones I did over here for cosine, I have to add the 2 pi k to represent every possible solution, all of the infinite numbers of solutions that I'll get as I do extra laps around the unit circle. Remember, every time I add a 2 pi to either one of these values, or to these angles, I end up back at the same point, and the sine of that angle is still going to be negative 4/5. All right, so that's how we can solve an equation. So this one was a really good problem because first we had to use this factoring method that we hadn't seen before in any of the other examples that I did, where I pull out that common factor. That allowed me to separate the equations, or separate those factors into two different equations. For the first equation, cosine of theta equals 0, that was one where I could actually use the unit circle and get my exact values, which I had over here. So we were able to use our trig hand and use the unit circle. The other one gave us something where we couldn't use the unit circle, so we had to use the calculator method and the inverse sine function to figure out the values, and then reflect that over into the other quadrant to get our other solution. So this one problem here contained a lot of the different methods that you need to use in order to solve trigonometric equations. Right? So it was a really good one to take a look at here. And hopefully it all makes sense as far as how to reflect the points over. Remember, you're using symmetry. So if this is 0.93 below the x-axis, this is also 0.93 below the x-axis, but it's not pi minus 0.93, right? Since I'm making a bigger angle here as I rotate around this way, I have to do pi plus that 0.93 to get that other angle that's over there. All right, so hopefully that all makes sense. There you go. Almost 15 minutes just to solve one single trigonometric equation. When you're doing these problems yourself, it shouldn't take so long. These take longer because it's me explaining what's going on and pointing out different things. But if you just sit down and solve it yourself, it shouldn't take you 15 minutes to do that. Unless you're not that familiar with it and you have to think your way through it a little bit. But I'm going to do some more videos where I solve even other types of more complicated trigonometric equations. So make sure you're checking out those other ones as well so you can see all the different methods and all the different weird things that can happen when you're solving these trig equations.